Okay. All right, so 15. Everyone go to number 15. What two reactions am I going to use to figure out the concentration of A? Which two react? You have three. You have trials. You have three trials. 1, 2, 3. They just don't list number 1, 2, 3. But which two am I going to use to figure out concentration of A?
Second and third.
One or two.
So to figure out the concentration of A, which two am I going to use?
3 and 1.
3 and 1. So I'm going to divide 0.64 by 0.32, right? So I'm going to have the rate here, just to review again what we're doing here. Sorry, I get really sloppy with my, is it B? Yeah. I get really messy with my rate laws if I'm doing it quick. Sorry. A and B. So we're going to divide the third and the first. So I'm just going to plug all the numbers in, solve for the exponent for A, because B and K are the same. So the rate is 0.64 divided by 0.32 equals, K's cancel, B's, or A's cancel. The B is going to be, I'm sorry. Did I do this right? Yeah. B's cancel. A is 3 divided by 1.5 raised to the x. So this is 2, this is 2, so x is equal to 1. So if I'm writing my overall rate law so far, that's it. A is to the first power. B, I don't know. We're going to figure that out right now. Questions on this? Okay. So after today, I'm just assuming you can do this. So I'm not really going to go over this again. So to find B, we would use 2 and 3. So we would do, actually, I don't need to do any math for this. Why? Paige, why don't I need to do any math for this? To figure out B. Like I can just look at the chart. Yeah, what's the same? So if you look at the rate, the concentration of B goes from 1.5 to 2.5. So the concentration of B increases while A is staying constant. The rate also stays constant. So if you add more B, but the reaction doesn't react faster, what does that mean?
It's 0.
Yeah, B has nothing to do with the rate. So it's 0 order. With respect to B, it's 0. So that's my rate law. You can write it that way, or you could write rate equals K, A. And you could write the first if you want there. All right? So this has nothing to do with the reaction, the rate. So determine the rate constant. Now I'm going to use the first experiment. I'm going to plug in numbers here, solve for K. So K equals 0.32 over 1.5, and that equals whatever I told you, 0.2133 seconds to the minus 1. That's 15. Questions? 16. All right, 16 is exact same concept. You take two of the trials where x is held constant to find y. You take two trials where y is held constant to find x. You get your exponents, then you write your rate law. I'll write down what I did here this morning. I actually had to do work because I couldn't just look up the answer key. I know, life is tough, right? So Tristan, when you got home last night, you just did your homework?
Yep.
Did you two have to do it after the game as well?
Yeah.
What about anybody who plays anything or does anything? Do you always do your stuff after the events?
Yeah.
Really? Does anybody go home and just like do your homework right away? Or do it right after school?
Again?
On any day?
Oh, yeah. Used to.
When I was younger, when I was younger, like freshman, sophomore, I never did that. I probably did it. I don't know why I remember this, but I do. I used to do it later, but then as I got older, I used to just bang it out right after school, so I had the evening to do whatever I wanted. So, well, yeah, I mean, depends if I practice or whatever, but then that obviously changed things. But doesn't it? You guys get tired doing stuff? You're just like, I don't want to do So why don't you just do it earlier?
Game
It's
day.
You have between 3,
Yeah,
2:45, and 7 o'clock. Or,
No, 5 o'clock.
I had a musical rehearsal yesterday, so.
hey, whatever, you know, I'm not judging, I'm just saying, isn't there a better method? But I guess not. You guys are doing your work, that's fine. Alright, so this is what I did here for y. To figure out y's exponent, that's what I did. I forget what two experiments that is, but I got 2 equals 2, so x equals 1. So rate with respect to y is first order. X, I did 0.509 divided by 0.127 equals 0.4 to the x over 0.2. I'm just using x as a, you can use any variable you want. You want to use the letter f, be my guest, all right? It doesn't matter. So don't let me confuse you with that. This is just the exponent here. With respect to x, this is 4, and that's going to be 2. So now, this exponent is 2, that exponent is 1, so the rate law is k x squared times y to the first, so that's third order. So that's how I got that. Now, they give you concentrations. They say, all right, what is the rate, or it says initial rate, I believe. Initial rate. So, there's 2 terms I don't want you to get confused with. Average rate and initial rate. Average rate would be like if you calculated the rate for every single trial throughout a reaction here, or if you look at this chart and you calculated the rate for all of these and then averaged it, that's the average rate over the entire spectrum there. Whereas an initial is a specific point in time in the reaction. And that's what, the initial rate is basically what they're always going to ask. When you solve for rate laws, they're not going to ask for average rate. That's not the point of this. The point is, if you know the rate law and they give you a specific concentration for both at that moment, as soon as those react, what is that rate going to be? So that's what they mean by initial. Determine the initial rate of disappearance of x when the concentration of x is 0.3 and that of y is 0.4. So we know the rate law before we can solve for rate, because that's what we have to do. We take concentrations, plug them in here. What do we have to solve for? So they gave us x and y. It's 0.3 and 0.4. What did they not give us? Okay. So if you want to solve for rate, we got to solve for this first. So you use the method that we've been doing to find the rate law, then pick random experiment. I don't care which one. I think I picked the first one. Plug in a rate, plug in the concentrations from the chart, solve for k. Then use that k with the numbers they gave you in the question. So if we solve for k, here's what I did. I did k equals 0.053 divided by 0.1 squared times 0.5, and that's 10.6. 10.6, and because it's third order, it's minus 2 minus 1. Now I plug that in for k to solve for rate based on what the question is asking. This is a great question because it covers everything like an AP test would ask. They would give you data, they'd say, what is the rate law? What is the order? They might even say, what is the rate constant? So that's the progression. They give you the data, you solve for this, you answer some questions about order, and then they say, okay, what's K? And then they say, all right, what's the rate if they give you concentration? So that's kind of how all these questions work. There's different variations, but that's, if you can do this type of problem, you can do any type of problem like this. So that's K, and then the 2 concentrations they give us, 0.3 squared times 0.4, and that is 3816, and molarity per second. So units is a big deal there, all right? And I would always advise you guys at least 3 sig figs on everything. I put 4, but at least 3 sig figs for any calculation ever, just in general. I've said that before, but questions? No questions. Okay. All right. So now the decomposition of the insecticide. All right. So this was a first order problem. All right. I took the picture of it here. It's kind of wordy, so I figured we just do it for homework instead of in our notes. So who can tell me what equation are we using from the equation sheet? There's two that they give us, one with natural log and one without. Which one are we using? Natural log means first order, so natural log of a sub t minus natural log a sub 0 equals negative kt, right? So, we read the, oh, does anyone have an answer for this one? What'd you get, Nicole? Yep, 2.75 times 10 to the negative 8. That is the answer to part A. Who has an answer for part B? Go ahead. 0.352 years. I got that too. Anybody else? A or B? All right. Anybody? Bueller? You guys didn't get that? Yeah, who gets it? All right, moving on. So, let's read the question. All right, the decomposition of an insecticide at 12 degrees is 1.45 years to the minus 1. So I'm hoping you read that and you think, okay, what is that? Where does that number go here? What is that variable? What is it? Someone said something. Is that you talking?
Yes.
Okay. I feel like your mouth wasn't moving. Yes, this is 1.45. That's the rate constant. It's always time to the minus 1. It's per time, right? Okay. Quantity of this insecticide is washed into a lake on June 1st, leading to a concentration of 5 times 10 to the negative 7. Let's see, of water. Assuming the average temp is 12, because remember, if temperature changes, rate constant changes, and everything changes. You need to have a constant temperature for these types of problems. So what is the concentration of the insecticide June 1st, 2 years later? So, what's the starting concentration? What am I going to put in right here? Because we're solving for this. This is what we're solving for. That's our x. Concentration at time t, which is 2 years later. So what's the initial concentration? So Liz, what'd you plug in here?
The 5
Yeah, 7, what they gave us. So the initial concentration goes here. So the natural log of 5 times 10 to the negative 7 goes here. Minus, this is going to be, minus, that's going to be natural log of x. So x is what I'm solving for. I know k is 1.45. What's the time? 2 years. 2 years. I'm not putting in all the units, obviously, as long as you know your ending unit. So the unit here is grams per centimeter cubed, so that's going to be units here, grams per centimeter cubed, right? It's concentration. All right? So we'll do this in steps here. So who set it up this way? Okay, the reason I asked that is maybe you set it up right, you just didn't do the math right. So try and help me out here. Were you guys confused as to which one you're solving for? Yep. Were you confused as to where that was? Or did you put this in for time maybe? No? Alright, I don't need to go through everybody's confusion, but it's easier for me to kind of explain if I know what you were confused about. So let me just reiterate here and go over it. This is the initial concentration because it says on June 1st, that's the concentration. It says 2 years later, they want you to calculate the concentration. So 2 years later, that's time t, right? That's 2 here. So this time is 2, because they told us 2 years. That's x because they want to know after 2 years, what's the concentration? Well, it's decomposing, so it should be smaller, right? So it should be a smaller number than this. Okay, so there's the setup. Now, if you don't like doing that, you can always get this concentration by its, you can just add this over to in the first place. Some kids like to rearrange it ahead of time. I think I said that a bunch of times. I know Mr. McConnelly teaches that. So if you want to add this over here first, so negative kt plus natural log of a sub naught equals this, that's fine. However you want to do it, but all right. So now when I do this calculation here is negative 2.9, so that's negative 2.9. This is natural log of x minus natural log of 5 times 10 negative 7 is, wait a second,
This supposed to be a negative 2.
no, this is negative 2.9.
No. So 5 times 10
Yeah.
to the negative 7. Is that supposed to be a negative 2 to the negative 7?
Negative 7.
Oh, maybe I did this
Yeah, that's a 7. My 2's have little curly Q's.
one.
That's a 7. Alright. This is 14.51, but I think it's negative. Yeah. Right. So so basically what I have, I kind of skipped around. I don't have the steps here, sorry. So natural log of x equals negative 2.9 minus 14.51. That's essentially what I have. So negative 0.29 minus 14.51. Sorry. I'm trying to do this like kind of in my head while looking at my notes. So this is actually what I have written down. Okay. Negative 2.9 plus negative 14.5 equals negative 17.41. So the natural log of x equals negative 17.41. How do we use the calculator to solve that? Like how do we actually, what's the buttons we push? Second natural log, negative 17.41. And really that means e, right? E raised to the negative 17.41. Right? You guys know that or whatever. So, but honestly, I'll be, you know, as long as you know how to type it in the calculator, you don't need to explain this stuff and drive. You don't need to get into any of that. Just can you use it to get the answer? So, anyways, you do that, and we get 2.75 times 10 to the negative 8 grams per centimeter cubed. So if you were to just graph the concentration of A versus T for first order, it would be a half-life graph. So that's without natural log. If you take a natural log, then it becomes a linear relationship. So that's why this equation exists. It's a lot easier to use a linear relationship than a curve, right? A slope that's changing versus one that's constant. So that's why we're using natural log to do these. All right, so that was A. B. So now it wants to know how long will it take for it to drop to 3 times 10 to the negative 7. So you know the initial is 5 to the negative 7. The final is 3 to the negative 7. Essentially this one, they give you everything you need. You're solving for t now. You're solving for t. So it's going to be the natural log of 3 times 10 to the negative 7 minus natural log, heck is that number again? 5 times 10 to the negative 7 divided by negative 1.45, that equals t. So you're solving for t, so you're just literally doing that on the calculator, and it equals 0.352. So if you didn't get B right, the only thing I can speculate here is you were just confused how to set it up. So the initial is still the same. They're giving us that. They want to know how long it takes. It took 2 years to go down to 2.75 times 10 to the negative 8. How long would it take to get down to this? Less time, because this is a larger concentration than the answer to A. So that's how we would do that. Big mistake kids make on AP tests. Let's say this was given on a test. They would label seconds here because I use seconds so much. The book uses it so much. You get used to writing seconds, so you would lose points for the unit. Make sure when you read the question, you're paying attention to that. What's the time? Is it seconds, hours, minutes, whatever? Okay, put that away. Take out your notes. All right. Let's see. In the book. Did we do in our notes that practice problem on the bottom of 583? We did, right? Go to 583, look at the bottom. And you had to calculate the half-life. Didn't we do that? I wanted you to use I wanted you to use this to solve for half-life instead of the shortcut equation. Yes, we did that yesterday. Okay, I'm not going to do another half-life with you then. Okay. The thing is with half-life problems, you can just make them up. Make up concentrate 1 and 0.5 or whatever you want. All right. Or if it's first order, if it's only first order, then you can use, what is it, 0.693? Right? What's that number? 0.693 over, yeah, 0.693 over K. If it's a first order, you can do that. Because first order, the concentration of the starting reactant doesn't affect the time. Second order, it does. 585 is where we left off. Pseudo first order reactions, again, just an overview. What does that mean? If you have two reactants, but one is incredibly more concentrated than the other, and I tried to use the example of like test questions. If you have 1,000 test questions and you get one wrong, that's like hardly going to affect your grade. But if you have 2 test questions and you get one wrong, that's 50% of the test, right? So that's the analogy I'm making with you there. I'm not going to have you do a whole lot with that. I'm just trying to explain a little bit of like what the heck that is. So a pseudo first order means it looks like it's second order because you have A to the first, B to the first, but the concentration of B is so high that any change in B, any small change in B doesn't really affect it. So really it's just A that affects it. That's all that really means. I'm not going to worry about that too much. All right, so let's see, zero order reactions. Go to page 587. If you look at the bottom of 587, there's your zero order reaction equation. That's not on your equation sheet. All right, so, but I do think it's useful to try and remember. You have your first and second order. Just try and remember zero order, you just take away the natural log. You don't need the natural log for zero order. First order, you need the natural log. Second order, it's 1 over concentration, and they're right on there for you. You don't have to remember the equations, just remember which one's which. Zero order, you take away the natural log. And the reason for that is because when you graph the concentration of A versus T, it's going to be linear already. For zero order, it's going to be linear already. So just like on top of 587, it's already a linear relationship, so you don't need to take the natural log. So hopefully something I'm saying here sticks. I know it's probably a little overwhelming, or when I'm just saying things out loud. But look at the very bottom. That's how you would figure out a half-life for a zero order. I can't even remember the last time I've seen one, so I'm not going to worry too much about that. Bottom of 589 summarizes everything we've been talking about here, sort of. The equations, the rate law, and then the half-life. There are those kind of cheat equations. But again, half-life calculations, you don't need those. I call them cheat. The shortcut equation, you don't need to know those. You just make up a concentration and then cut it in half, and then you can use the same exact equation we just did on that problem. So don't overwhelm yourself trying to remember all these equations is what I'm trying to say there. All right, so I'm going to give you, the book kind of craps out here on the rest of these here. Second order, yeah. All right, I'm just going to give you a sample problem here. I want you to use the second order reaction now. So we just did one for homework with the first order. I'm going to write one on the board for second order, and then we'll go over it, and that's going to be all the time we probably have. All right, so now remember, second order means if the concentration changes. Let's say the concentration doubles. What's the rate do? If it's second order. quadruples, right? So it's going to be an exponential relationship. All right, so here we go. One thing I do want you to write down though is that first order reactions half-life is constant, like a radioactive half-life. So like carbon-14 decays every 5,715 years. That's not going to change. But second order reactions, they can change. Half-life can change. And again, that's because it's not a one-to-one relationship. You have the exponent, the 2 then. Early in, so here's what I wrote in my notes if it makes sense to you guys. Early in a reaction, there are more reacting particles, so the half-life will be shorter. So because of the exponential relationship, it can change as it's progressing. Whereas in first order, it's a one-to-one ratio the whole time. And if that doesn't make a whole lot of sense, at least maybe you can remember that. These are kind of detailed type questions. I'm not super concerned with this. All right, here we go. Here's a question for you. All right. Okay, given the following reaction, you have NO2 plus, yields. NO2 yields NO plus 1/2 O2. This follows second order kinetics. The rate constant is 5.0 times 10 to the 6, which is like enormous, at 23 degrees Celsius. So it tells you second order, so then you know what equation to use, and you know the relationship of the rate and the concentration. It gives you the rate constant. Here's the first question, part A. If the initial concentration of NO2 is 0.065 moles per liter, calculate the concentration after 30 minutes. And then part B, calculate the half-life for BI if NO2 is 0.40 and then NO2 is 0.22. So the point of the problem is practicing using the second order equation, then seeing how the half-life will change based on concentration, whereas first order will not. And obviously we might get chopped off here. We got a little time, but we have plenty of time tomorrow. Did anyone see the throat punch here in this question? You're reading it, and you're like, ooh, this guy hit the throat.
Pardon the interruption. Will Riley Quay please come to the main office? Riley Quay to the main office. Thank you.
It's super quiet. It smells like really bad, like something's burning.
Like what?
Something's burning. You smell that?
Back here.
I do.
It's like really strong.
Oh yeah.
I don't know what that is.
It's, up front, it's really not.
Exploded.
Yeah. I don't have anything on back here. Not back here. It's not back there.
Yeah, it's like from here. Yeah, it might be coming
It's out
out
here.
from the
It's probably downstairs. It's out here.
Hold back.
Yeah, hold back. Yeah. All right. So, where's the punch in the face? Come on. What's the unit on the rate constant? N minus 1, S minus 1. What time does the question give you that it wants you to calculate concentration after? Minutes. So that's the question. It's not that hard, it's just annoying. So you have to convert minutes to seconds. That's not very difficult, but just that's little things that'll get you, right? So I assume you guys know how many seconds are a minute. If not, it's a little too late to drop the class, but I'm in trouble. So right now, obviously, we only have about 3 minutes. At least let's get A done. And then I'll give you the answers to B, and you can finish this up tomorrow. I'll write the answers for B right now. Over on the side here. But let's do A. Do A right now. I'll go over A, and then that'll be it. And tomorrow you have a bunch of fun things to do. Next lab, we're going to do the bleach. Next week, we're going to do the next lab, and it's going to be the bleach lab. So that'll be cool. You can see it. You can see the color change as the bleach reacts, and that we can measure the rate of that through absorbance. So hopefully it helps you understand stuff. B, so B, I, the answer is 5 times 10 to the negative 7 seconds. And I is 9 times 10 to the negative 7 seconds. I'm breaking my rule there with the 3 sig figs, but I'm just going quick here. Hold it. So I know we're out of time. 1 over A, I got 9 times 10 to the 8th, so I just plugged everything in. And then when I solve for A, it's 1. So A is, the concentration of A is 1 times 10 to the negative 9 moles per liter. So that's the answer to A. I used A, it's really NO2. So this really should be NO2 here. Hopefully that made some sense. All right, tomorrow, finish this problem and then do the other ones that the sub will give you. Or I'll text you, or you'll know what to do. Okay, thanks. Problem sets due. So, if you really need to text me tomorrow to remind or whatever, you can do that. It's not. I can respond throughout the day if you need me to. So, because I know it's due Friday.